Welcome back, welcome back, welcome back to Algebra II, Chapter 10, Section 5. We're learning in this book about conic sections, and now we are to our fourth one. We did parabolas, we did circles, we did ellipses. Yep, our fourth one, hyperbolas. Look how fancy and pretty this looks. I feel like Vanna White. So you know you've made it to fancy math once you get here. Okay, so what a hyperbola is remember I showed you on the conic sections where it comes from, and it's kind of like two parabolas. If it's this way, it's considered horizontal. If it's that way, it's these green lines, then it's vertical. It has a focus, just like the parabola. Each one of them has a focus. There are asymptotes that make an X here that they'll always get closer and never touch. The asymptotes, that's always fun to say. And if you go out and you draw a line from the vertex to the asymptote till it hits and then draw a straight right angle over, you get the vertices, you get the rest of the box. Yep. Okay, wanted to make sure that that's what they call them. Sometimes the names change a little bit. Okay, so like here we'd go out, whoop, whoop, and so these are your B's, those are your A's, and it kind of makes a box there. But it's just you go from the vertex over to the asymptote and down. And of course mine are not drawn very good. And then just the C are the foci, each one is a focus, plural is foci or foci. And, okay, so this one is horizontal. There is a formula for the asymptotes. It's plus or minus b over ax, plus or minus a over bx if it's vertical. Okay, so let's talk about horizontal first. In the formula, it looks very much like the one we looked at last time, but it's minus instead of plus, okay? If x is first and y is what is minused from it, it's horizontal. If y is first and x is what is minused from it, it's vertical. With these we have the formula like we did before, but instead where the other formula had minus, this one is plus, just like the Pythagorean theorem. A squared plus b squared is c squared. I think it's funny they write c squared first to try to make you not realize it or something. Let's see if there's anything else. They're equal to 1 again, just like last time. But these are hyperbolas. Okay, so here is an example problem. Also, in your apps, you have conics that you should learn how to use. Okay, so we're going to draw this, and notice it's in the wrong form. So we look at it, and this is supposed to be a 1. 36 is not 1. I'd much rather have $36 than $1. So I have to make it 1, and how I do it is dividing it by itself. And I can do that as long as what I do to one side, I do to the other. Those cancel out and become 1. And then 4/36 reduces to 1/9, and 9/36 reduces to 1/4. This is, so x is first, so we know it's horizontal. And notice that this is not a, it is a squared. So the square root of 9 is 3, so we know a is 3, and the square root of 4 is 2, so we know b is 2. So we know it's horizontal, so we go out to where a equals 3 and make a point, and we draw our swoosh. And then we go to a is -3 and make a point and draw our swoosh. B would be up 2 and down 2, we can put some dots there. And we can get our focus by doing our formula here. I think this is wrong though. Anyway, yeah, I think that was wrong because, but anyway, they didn't bother. I started getting the focus, but they ended up not doing it, and I thought, oh, I don't need to do it. They did it over here. So don't worry about the focus. You could solve for it by doing 3 squared plus 2 squared equals c squared. So this is 9 plus 4 equals c squared. So this is 13 equals c squared, square root of 13. And I think it's smaller than what I put here. I don't think I bothered putting it in the calculator. All right, so here's another one. This time, notice that we are given the vertices, and the foci. And then notice that these are in the y, so we know it's vertical. Because see how, if it's vertical, the points are on for the thing are on the y-axis. If it's horizontal, the points are on the x-axis. So y's have something, x's are 0, so we know this is vertical. So we can see that a is 2 and that c is 3, and we can solve for b. A squared plus b squared is c squared, 2 squared plus b squared is 3 squared, minus 4 from both sides, b squared is 5, b is the square root of 5, which is about 2.2. So we can put it in our formula, and it is y squared over 2 squared minus x squared over b squared equals 1. Square these, so that's 4, and that's 5. Square root of 5 squared is 5. And then we can graph it. We go to 2, put a dot. We could put our focus on there too at 3 and -3. That looks like a negative. I didn't draw it very good. And then go swoosh, swoosh. And you can also put in your b if you want to. It's plus or minus square root of 5, which is about plus or minus 2.2. Ta-da! Fancy math. I hope you enjoy it. I do. And the next part I think is even more interesting. So come back and we will do chapter 10, section 6, which is where we get to compare all the formulas and learn how to tell which one it is. Math is great.